episode 5 of my Python crash course. Today I'm going to be talking about functions and libraries, which are two of the last concepts I'm going to be teaching in this series, or the last two concepts I'm going to be teaching, and I'm going to be explaining how we use them, as well as how they're going to be important to our game. So in the last episode, if you guys remember, we talked about loops. I introduced the while loop, which takes a condition, and whenever it repeats whatever's inside there until that condition becomes false, or until the loop is broken. And I also talked about the for each, which we'll also be using, where we take an array or a string, as I hinted at sort of over here. And we take each one of its elements and we assign that element to a variable. In this case, we're taking wordless, and all of the elements from the first to the last one is being assigned, or word is being assigned to those one by one. And we can do something with word, so we can just break up wordless into all its individual words. Today, I'll start with functions, and if you guys remember episode 1, we kind of made one already, which is this define, main, open close bracket, and a colon. And everything after that is on a tab line, and in order for us to use it, we need to call its name. In this case, the name is main. So over here, I'll talk about what functions are. I mentioned they're called sub-recipes that the butler adds to the main recipe. So, if you guys remember, I compared Repl.it to a butler, and the butler looks at a recipe and it follows what it does. But we don't just have to give it one recipe. We can also give it 10 others, 50 others, 1,000,000 others, or just, one. So let's say there's a recipe for chocolate frosting that we also give it, and then in the chocolate cake recipe, we say make chocolate frosting, so it goes to the other recipe and it reads that one. Exact same thing as we're doing here. In this case, our chocolate cake is the defined main function, and our chocolate frosting is any function we add to it. In this case, I'm going to add one more. But in order for me to do that, I'm going to have to make a few changes here. What I'm going to do is, I'm going to call this word exists, and you'll see why later on in the video. And I also have to change this one, because remember, variables, the names have to match with variables and functions, otherwise Repl.it, or the butler, doesn't know what you're talking about. So, let's make one more. Again, if, notice it turns blue. We're going to call this word exists, open close bracket, and because we have open close bracket, this makes it different from the variable word exists, but we'll be changing that later on. And I'll hit colon and enter, and you notice by default Repl.it puts it on a tab, which is great. And whoa, we can ignore that. What we want to do is, you know how here we have word exists and we're checking if all of the characters or letters used in our word actually exist here? Well, there's this great thing we can do is, instead of putting it here, we are going to remove it. Call this, and I'm going to leave it empty for now, but I'm going to fill it up in just a second. I'll put it here, and just before it, I'm going to put a keyword called return. Now, what does return do? Oh my goodness. What does return do? Well, return is this excellent method or function that comes by default with any function that you make. So all of the functions, all of like if and break and count, .count, and all of the infinite many functions that ever exist, the majority of them, almost all of them, will have return. And return says, I want to take this variable, whatever the variable is at the end, and give it to wherever I call the function. So if in this main, all the way at the bottom, I say return 0, or return 1, which normally means, hey, the function's working great. If I were to say print main, open close bracket, it's going to run main, so it's going to do all the normal main function stuff, but it's also going to print out the number 1. which seems a little bit complicated, but all good. What I'm next going to do is over here where we deleted that, I'm going to write word exists, open close bracket, all good, great. Now, word exists possibly bound, should be good, should be fine. I can run this, and it works fine until we get to here. I'm not going to show that. And the reason is, I'll tell you that this is not going to work how we want it to. Why is it not going to work? Well, I'm sure you guys can see if I zoom in. I'll just zoom in. You notice that here and here and here, X and letters, both variables, it doesn't understand. Like, where are these? Repl.it or the butler is telling us, hey, what is this? What am I looking at? And you might tell the butler, well, wait a minute, it's right here. This is X, and this is letters. Why is that? Why don't you see it? Here's the thing. Just like our butler has multiple recipes, the recipe of chocolate frosting doesn't know that the cake has eggs in it, for example. This is just the most basic example. And this is intentional because in more secure environments, let's say a bank, your bank information is stored somewhere in the code's servers as a variable. It's not that simple, but it's good enough for my explanation. And if it was just accessible anywhere, a hacker could just come in, look for the username and password, sign in, transfer to their own account, yay, he leaves with your money. Not great. In this case, we want those here. How do we bring them here? We bring them here by putting them inside these two open close brackets. I'm sure you guys remember, for example, input takes any string and it puts it here. Our word exists function is going to take X and letters. So it takes two variables. One of them assigns X and one of them assigns letters. What I will do though is, because this is a separate function, I'm going to rename X into word, even though down here I'm going to use it as X and letters. Because remember, this needs to match this. Still a little bit confused, but I'm sure it should be fine. If not, I'll just change the name of this. But it should be alright. I'll run it in a second. Now, I have not explained why we use functions. Well, in the very first episode, I mentioned that putting main here and running it down here is obsolete. It doesn't matter if you were to remove these and put all of these on one indent, it will still work the same. But it's a formality and it makes our code neater. In this case, we have our very own function called word exists. So let's say we have somebody else looking at my code. Let's say I have a programming job. I don't know, making software for whatever. And let's say they need a function, say, hey, can you make this function for us? It needs to do this, this, and this, and all right. So I'll make the function. I'll name the function, and I'll name it something that makes sense to them. So they can come in, they read this, they're like, all right, I understand what this does. This is a very simple function. I'm not going to get paid to do this. I'm going to get paid to do more complicated things. This is not about getting a job. This is about making a game. So for our case, this is also good. Adding in comments would make things better. Sorry, I'm using old programming style, where you put a hashtag or a £sign or a slash or this number sign, whatever you want to call it, and then you can write a comment. This function checks if the word exists or the word is made of letters. But both comments and good naming and good organization, so putting this in its own function, makes our code neater. This one still has possibly unbound. Alright, all good. Alright, let's run this. I'm going to type in a word, break. And it says no. Well, why does it say no? It says this was referenced before this. Huh, that's pretty weird. So what are we going to do? Well, what I can do is I can make the function name different, check if word exists, and then down here I'll write check if word exists, and see if the same error pops up. It doesn't, which is great. If I run this, I can show what it's supposed to do, which is absolutely nothing. You notice this works exactly the same as the end of code from episode 4, which is perfect. That's what we want. We're creating this one to, in our case, to make our code neater and to make our code more understandable. But if we have the same 2 lines, the same 5 lines, the same 20 lines multiple times in our code, and with more complicated software and games, you'll notice that. Like, for example, I don't know, Minecraft has, no, Minecraft's not a good example. Anyways, I can't think of a good example, but anytime that this code is used more than once, and it's usually more than a line, if it's used more than once, we make a function, and then we just call the name of that function. And we can give it parameters. These are called parameters, and we're naming these parameters word and letters, and it's going to do something with word and letters, and it's going to return a variable. So it's kind of like a function in math, where you put in something and you get something out. You put in an x and you get y. That's pretty much functions. Again, like I mentioned, for our game, we're not going to be using them for super important things. We're going to be using them to make our code nicer. Other than functions, we have something called libraries. Libraries in the real world are a building. You walk in, there's a bunch of books, you borrow them, you do library things. Libraries in coding are massive collections of functions. So Python already has its own functions, like the input and the print and the array.append, and I will actually leave a list to, or a group of them, in the description of the video. But you'll notice that if you just look up Python functions and give it, like, you want, I don't know, array functions or functions to do something, then if you look it up, you'll see tons and tons and tons of them. Some are already in Python and some are not, which leads me to what I'm going to do. Libraries exist to bring in functions that already aren't in Python into Python. So going back to our butler analogy, I don't have a slide for it, but our butler is going to be given, let's say, a cookbook, and one of the pages in the cookbook has the chocolate frosting recipe. And so whenever it asks, if we just give them the chocolate cake and we don't give them the cookbook with the chocolate frosting recipe, it's going to be stuck and say, hey, I don't know what to do here, which, makes perfect sense. In our case, NLTK is a library that allows us to import the entirety of the English language dictionary. Yes, every single word in the dictionary can be here. So I'll stop this for now. Wow, I left it on too long. But I'll run it, and you'll notice it's going to do some things that don't really make sense. Oh, no, it's not. Why isn't it doing that? Oh, because it doesn't show, but I've already imported this. If you run it, something, text will show up and it says importing thing. Just leave it to run, and then when it gets to type a word, you can stop the program, and what it does is it's brought NLTK into Repl.it, into the butler. So the butler now has it, so whenever we need NLTK, we can use it. So with NLTK, we're going to make another function. You kind of get how this video is going now. Word is valid is what we're going to name it. Again, we want to make something that is easy to understand if somebody else looks at our code. And I'm going to give it a parameter called word. So whenever we call word is valid, whenever we use this name, we're going to need a word to do so, so this word. And at the end, we're going to return something. But for now, there we go. we're going to make a dictionary. And we're just going to make a variable called dictionary, and actually what it's recommending works fine. We're looking for set nltk.corpus corpus.words, open close bracket. I think that should still be fine. And we want to return if word is in dictionary. There we are. If I run this, let's make sure we have no issues. And it looks like not. Great. So what I've done is I've created a function. That function is going to look at the dictionary that we brought here with NLTK. And it's going to check if our word is in dictionary. Because otherwise, let's say I input a word called bloop. Which, actually I think that is in the dictionary. So if I enter blarg, which I know isn't, blarg is going to pass through this because it is made of letters, but it's not going to pass through this because it's not in our dictionary. And the reason we're doing that is because in our final game, when we're given 5-ish letters, we don't want to just accept any letter that exists, any word that exists, because otherwise you just put 10 letters in whatever order you want, hit enter, and then the computer's like, yay, you did it. Which, like, yeah, that's easy, but it's not fun. A game needs to be challenging. But anyways, that should be everything I have for today. The next episode, episode 6, is going to be my very final last episode, where we're going to make the game. And it might not look like it, but we've already kind of got a lot of the core elements here. We've got our letters stored in variables. Each one is an element called a string, which could be a character or multiple characters. And we also have arrays, which are groups of strings, groups of numbers, groups of whatever. We have our loop, which we're going to transform into our game loop. I won't spoil much, a lot will be said in the next episode. And then we have checkers. So we want to make sure that the word that we put is made of letters. We want to make sure it exists in the dictionary. And I'm going to add a few more rules later on. And we also have the initial, or we will have the initial, here's the 10 letters randomly chosen. And we're also going to add up the points. And then we're going to, hey, you won, here's your points. And that's pretty much what we're going to be doing in episode 6. Stay tuned, and have a great day, and goodbye.